Hi everyone, we're looking at our next type of transformation, which is the rotation. So let's talk for just a second what our definition of a rotation is. So specifically, a rotation is a transformation that turns a figure around a given angle, such as 90 degrees, 45 degrees, 180. With these rotations, we can actually have something that is more than 180. We're going to be looking at a 270-degree angle rotation with these examples. So let's check out our first kind of rotation, which is to rotate a figure 90 degrees. So there's our clue there, 90 degrees about the origin. Now, before we specifically get into rotations, because which way do we rotate 90? Do we rotate to the left or do we rotate to the right? So specifically, our first kind of rotation is always counterclockwise. Which means we're going to turn it to the left. Unless it specifically says to go a different direction. So in this case, all it says is 90 degrees about the origin. That means we are in fact going to turn left. Because again, it doesn't specify a different direction. So we go counterclockwise to the left. Now, why do we go to the left first if there's no other direction? Well, because that's the way the order of your quadrants fall in a grid. They start quadrant 1 is all positives, and that is our, and then quadrant 2 would be to the left of that, and then it follows the pattern. So it follows the order of your quadrants for a graph. Now, like our other rules for translations and reflections had certain ways to follow, so does a rotation. So when we rotate a shape 90 degrees to the left, our pattern says to change the sign of y. Keep your x exactly the way it looks. Now, if you notice, the two positions have changed. So we're going to change the sign of y and put that number first. Keep x the way it looks, but put that number last. So let's see what happens when we apply this rule to our coordinates. So we'll get all our coordinates first, and then we'll go graph this. All right, so for our first one, we have 2, -1. So we know x is my 2, y is the -1. So the rule says first, change the sign of y. So change that y. So -1 becomes a +1. Keep the x exactly the way it looks, but put it last. So there's our first point, A prime. Now let's do B. So change the y. +1 becomes a -1. Keep the x exactly the way it looks, put it at the end. Same thing for our last one. Change the y, so -3 is what we get. Keep the x, so +3 at the end. Let's graph our two set of points and see what happens. All right, so our first point is 2, -1. Oops, make that a little bit bigger. So there is my A. B is at 5, 1. And C was at 3, 3. So there is our original shape. And again, we're going to rotate this 90 degrees counterclockwise, meaning to the left. Now we've got our new points. So let's graph those and see what happens. So the first point we have A prime is at 1, 2. B prime is at -1, 5. And C is at -3, 3. So there's C prime. So we can see we do have the same shape here, the exact same triangle, only now it's been turned around the origin 90 degrees to the left. So let's zoom out so we can see our new shape here. All right, so again, we can see that it was turned from that origin position. So it's all revolving around that point. Now, another kind of rotation that we work with is the 180-degree rotation. Again, about the origin. So like before, we are going to move to the left because it does not specify a certain direction. So let's get our points up here. So if I'm rotating 180 degrees, let me zoom in here for this. We're going to change the sign of the original X, but leave it first. Change the sign of the original Y, but leave it last. So just a sign change. So let's see what happens to our set of points here. All right, so I have -4, 3. So again, change the X, put that first. Change the Y, put it last. So sign change for both. Let's do B prime. So 1, 2, change the X, it's first, so -1. Change the Y, put it last, -2. And the last one, C prime, change the X, so +3, put it first. Change the Y, so +3. And put it last. Let's graph these out. So let's get your original. -4, 3 is my A. Sorry, I'm going to make that a little bit bigger. B is at 1, 2. And C was at -3, -3. And here was our original triangle. And again, we're going to rotate this 180 degrees to the left. So let's see what happens to this new figure. All right, so A prime is at 4, -3. All right, so A prime, -1, -2 for B prime, and C 3, 3. C prime. All right, and here is my new triangle. And again, we can see that it is in fact rotated. It has been rotated 180 degrees. To create our new image. Now, the last rotation I want to look at is the 270-degree rotation, still about the origin. While a 270-degree rotation has its own rule that says keep the Y exactly how it looks, but put that number first, change the sign of the X, and put that number last. So let's see what happens here. All right, so we have 5, 0. So keep the Y, put it first. So 0 will be first, change the X, so -5 will be last. Sorry, I'm going to make that a little smaller here. So 0, -5. Same thing for the next point, keep the Y. So we're keeping the -4, but changing the X. to -3. For C, keep the Y, so -4 stays. Change the X, so +2 becomes -2. And then our last one, 0, 0. And guess what? It stayed exactly the way it looks because it's got no sign to it. So changing the sign of a 0 does nothing. Now, again, because 0, 0 is a point on the rotation, another reason why it stays exactly how it is. So let's graph these points and see what our original shape looks like. And then we'll graph the new image. So 5, 0 for A. B, we have 3, -4. C, we have 2, -4. And then D was at 0, 0. All right, so there's our shape. Bear with me, I'm just coloring it in to make it a little bit easier to see here. And so we're going to rotate this 270 degrees about the origin to the left. So let's graph our new point here now that we've applied the rule to it. All right, so we have 0, 5 for the first one. Sorry, 0, -5. So my A prime is now down at the bottom. -4, -3. So there is B prime. We have -4, -2 for C prime. And then remember, D prime stayed at the origin. And so there is our new shape. Our trapezoid turned 270 degrees about the origin, which again means we turned it to the left. So hopefully you can see that turn happening a little there. Now, there are some things to remember when in fact a clockwise or right turn is used. They follow the same patterns, but not in the same order. So they are somewhat similar. Oops, make that a little bigger. So keep these patterns in mind whenever you see your clockwise or to the right rotations. So a 90 degrees counterclockwise is the same as a 270 clockwise. So in other words, 90 degrees to the left is the same as 270 to the right. They end up in exactly the same places. 180 degrees counterclockwise is the same as a 180 degrees clockwise. Sorry, let me zoom in on that for a second. And then our last one, a 270 degrees counterclockwise is the same as a 90 degrees clockwise. They have the exact same set of rules. They will be in the exact same places. But again, it's just a matter of which direction do you have to turn. Again, 90 degrees to the left is the same as 270 to the right, same rule. 180 is the same either direction. 270 to the left is the same as a 90 degrees to the right. So guys, I hope you enjoyed learning a little bit about your rotations. Please don't hesitate to reach out to me if you have any questions.